morning children. Today we are going to discuss the toppers IIT-JEE NEET Foundation 7th class. The work power energy. Work is nothing but whenever the force acts on a body displaces in the direction of the force. Power, the amount of work done per unit time is called power. Energy, capacity to do work is called energy. So work, energy have the same units, power have different units. Work and energy have the units of joules, and power has the units watts in the SI system. So there are some conceptual questions we are going to discuss now. So conceptual understanding questions. See, the first question, work done on the system by the resultant force is equal to dash. See, there is a work done on the system by the resultant force is equal to dash. So in this, actually the options are change in its mass, change in its kinetic energy, both 1 and 2, and neither 1 and 2. See, the work is equal to energy. See, according to work energy theorem, work is equal to energy. So the change in kinetic energy, work is nothing but change in kinetic energy. So work is force into displacement. Work is nothing but force into displacement. See, force is nothing but mass into acceleration into displacement. So this can be written as mass into acceleration into displacement. According to the equation, v square minus u square is equal to 2as. V square minus u square is equal to 2as. So this can be written as m into of m. Okay, so that v square minus u square. So that becomes of m v square minus of m u square. So it is okay. So kinetic energy, final kinetic energy minus initial kinetic energy. That is nothing but change of kinetic energy. So change in kinetic energy is the right answer. See, the remaining options are change in its mass is correct, wrong, and both 1 and 2 are wrong, neither, okay, 1 and 2 are wrong. See, option is change in its kinetic energy is the correct answer for this question. So coming to the next question. See, the next question, if the body has mass m, the momentum is p, then kinetic energy will be what? So in this, what we have to, the kinetic energy should be expressed in terms of momentum and mass. How to express that? So to find out that, see, kinetic energy is equal to, okay, see, half mv square. So this half mv square, kinetic energy equal to half mv square. So to make it this equation, multiply with mass and divide with mass. So half into m square v square upon m, multiplied with mass and divided with mass. So m square into v square can be written as v dot v, v into v you can write. So that can be written as half into mv into mv upon m. See, mv is nothing but what? The momentum, mass into velocity. It is denoted by p. So mv can be written as p and another mv can be written as p. So p into p, that is p square. So p square upon 2m. So the kinetic energy is expressed in terms of momentum, that is p square by 2m. See, the options if you see here, one is p square by m, this is wrong answer. Another is p square by 2m, this is the correct answer. And m square by 2p, wrong answer. P by 2m, wrong answer. So the option, okay, so B is the correct answer for this question. So coming to the next one. See, the next question is third question. Third question is the simple one, I think. So then fourth question here. So the potential energy of a freely falling body decreases continuously. What happens to the loss of potential energy? See, here if you observe, there is a potential energy of a freely falling body. See, if the body is there at certain height, it has got the potential energy. But this potential energy, when it is falling, so definitely the height decreases, potential energy decreases. So then there is certain loss of potential energy will be there. So what happens to that? That loss of potential energy will be converted into kinetic energy. See, potential, according to law of conservation of energy, energy neither created nor destroyed. It transforms one form to another form. If energy disappears in one form, then reappears in another form. Energy remains constant. So that's why whatever energy lost here, that can be converted into kinetic energy. So the converted into kinetic energy is the correct answer. The remaining options, okay, so these are wrong, this is wrong, magnetic energy, and none of these also wrong. Converted into kinetic energy is the correct answer for this question. So next question, the potential energy of a body at a height ch is mgh. When it is falling to the ground, see, when the body is falling to the ground, then so what will be there? So potential energy. When what will be the kinetic energy? Actually, when the body is falling to the ground, what will be the kinetic energy? The complete question is, then kinetic energy is equal to what? Then kinetic energy is equal to what? See, if the body is there at certain height mgh, okay, so when it is falls to the ground, so that kinetic energy will be equal to the potential energy. Kinetic energy will be equal to the potential energy. So option mgh is correct according to law of conservation of energy. So there will be a, see, potential energy will be converted into kinetic energy when it is falling, okay, so to the ground. So this is about the fifth question. Then sixth question, how much is the mass of the man if he has to do 2500 joules of work in climbing a tree? See, that is 5 meters tall. The person is there at a height of 5 meters. So he wants to carry, he is doing a work of 2500 joules. See, that the mass of the man will be, how much it will be there. So here, see, what we have to find out, actually mass should be find out. There is certain work is given, work is equal to mgh, the potential energy. The work is nothing but potential energy gained by the position, because the person is raised to certain height, so there is certain work will be done. That work is nothing but the potential energy which is gained by the, okay, body. Here the work is mgh, so mass is nothing but, here we have to find out gravity. See, gravity you can take 10 and height is 5 meters. The work done is 2500. The work done is 2500 joules. So it means it is 50 m equal to 2500. So then m equal to 2500 upon 50. So 50 is 2500. That's why, so 50 kg. So in the given options, 30 is there, wrong answer, 40 is there, wrong answer, and 50 kg is there as the option C. So then 45 kg is wrong answer. So option C is the correct answer for this question. So next question. A man carrying a bag of mass 25 kg up to a height of 10 meters in 5 seconds. Then work done by the force in taking a bag up to 10 meters. What will be the work done? See, here also if you observe similar type of question, but just reverse, you have to find, instead of mass you have to find the work done. See, work done to raise mgh. So mass is given, so the mass is 25 kg. G value here you have to take 9.8. Of course it should be mentioned in the question. So the height is also, see, 10 meters. The height is 10 meters. 50 seconds is the extra data what it is given here. So it is nothing but 25 into 98. 25 into 98. If you multiply, okay, see 20, 98, 25, 5 8 ja 40, 5 9 ja 45, 49, 2 8 ja 16, 2 9 ja 18, 19, that becomes 25, 50. So that is, sorry, 2450, 2450 joules. So the option A will be the 2450 joules. See, 2400 joules wrong answer, 2350 joules wrong answer, okay, 4250 joules wrong answer. So option 2450 joules is the correct answer. So the next question, eighth one, the work done is always greater than the energy spent, less than the energy spent, or sometimes greater than, sometimes less than, and fourth option equal to the energy spent. See, work done is always equal to energy. That's why option D is the correct answer. The remaining options are all wrong. The remaining all options are wrong. Okay, so equal to, work done is equal to energy. So the next question, as a body rolls down on the inclined plane, it has dash. A body rolls down on the inclined plane, it has dash. See, when a body is rolling on the inclined plane, let us take here inclined plane. This is the inclined plane. So body is there, it is rolling on the inclined plane. While it is rolling, so definitely there is a energy, motion is there, kinetic energy will be there. Body is there at certain height, there is a potential energy is also will be there. So potential energy as well as kinetic energy when it is rolling, okay, from the certain height, so there are both A and B are going to be there. So potential energy as well as kinetic energy, both A and B is the correct answer. Say only kinetic energy wrong, only potential energy wrong, neither potential nor also wrong, only correct option. So both potential energy and kinetic energy. So next question, 10th one, in which of the following cases the potential energy of the spring is minimum? In which of the following cases the potential energy of the spring is minimum? There is a spring, so the springs usually, so we observe it can be see, it can be, okay, so compress as well as you can do the extension, something like you can expand, like so you can increase the length of the spring and decrease the length of the spring also by applying a force. But when the spring have the minimum potential energy, the minimum potential energy when it is in the natural length, when the spring is in the natural length, it will have the minimum potential energy. See, when it is in the compressed state, it will not be there. When it is in the extended state, it will not be there. And so natural length and it's kept at a height, it is also not a minimum potential. So minimum potential will be available at only at the spring when it is at the natural length. So the next question, see, these are all the conceptual understanding questions. Then there is a single correct answer type questions. Single correct answer type questions. See, the first question, see, power is equal to dash. Power is nothing but work upon time. See, power is work upon time. So if you observe, see, work is nothing but force into displacement. See, force into displacement upon time. Displacement, rate of change of displacement is called velocity. So power is equal to force into velocity. Power is equal to force into velocity. In the given options, if you take force into acceleration is wrong, and velocity into acceleration is wrong, force into time is wrong, only option force into velocity. Option A is the correct answer, force into velocity. So this is about the 11th question. 12th one, power of an electric bulb. Power is nothing but what? Energy consumed, the rate of energy, you can also call rate of energy. That is, power is nothing but energy consumed by the time taken. Energy consumed by the time taken. This is the correct answer. So the remaining options, if you take the remaining options, time taken by energy wrong, and energy consumed into time taken wrong, none of the above is wrong. So answer is energy, power is nothing but the rate of energy consumed. So energy consumed of a appliance in unit time. For example, bulb is there, it consumes certain energy in certain time. So that is nothing but power. So next question. See, 1 kilowatt is equal to dash horsepower. See, horsepower kilowatt relation. This is very very important. Horsepower is nothing but, see, usually horse, there is certain, so the horse is the animal which is going to be there, okay, so which will have the high power, okay. See, something like it can do the large amount of work in a short time. That's why they are, okay. So horsepower, 1 horsepower is equal to, actually 1 horsepower is equal to 746 watts. This is the relation, constant relation. So I want 1 watt equal to dash horsepower. 1 watt equal to 1 upon 746 horsepower. So now 1 watt, 1 kilowatt. 1 kilowatt is how many watts? 1 kilowatt is 1000 watts. 1 kilowatt is 1000 watts. Hence, for 1000 watts, how many horsepower? 1000 watts equal to 1000 upon 746. 1000 upon 746. So 1000 upon 746 is nothing but approximately you will get 1.36 horsepower. So option C is the correct answer. The remaining answers 1000, 746, 0.746 are the wrong answers. Only 1.34 horsepower is the correct answer. So next question. A man does 200 joules of work in 10 seconds. The boy 100 joules of work in 4 seconds. Then who is delivering more power? See, there are two different persons. Okay, one is man, another is a boy. See, first of all, see, we calculate manpower. See, to calculate manpower, let us take the man. See, the power is equal to work by time. Power is work by time. See, work is how much? 200 joules of work. 200 joules of work in 10 seconds. See, man does 200 joules of work in 10 seconds. That's why, see, 20 watts. This is the power of the man. The power of the man is 20 watts. Similarly, if you try to find out boy, see, the boy, the power is, he is doing how many joules of work? 100 joules of work. See, 100 joules of work in 4 seconds. In 4 seconds, 100 joules of work is doing. So 100 upon 4, it is 25 watts. See, 25 watts. Here, man is 20 watts, boy is 25 watts. So who is delivering more power? So boy is delivering more power. Hence answer is option B is the correct answer. Man is wrong, and both are same power is also wrong. We cannot say is also wrong. Answer is boy. Boy delivers more power. So the next question. See, time taken to do the work of 440 joules. 440 joules at the rate of 11 watts. See, here we have to find out time. See, power is nothing but rate of work done. Power is equal to rate of work done or work by time. So if you take, see, here the time taken to perform 440 joules of work. See, work is given 440. Work is given 440. So power is given, that is 11 watts. Now time you have to calculate. So how to calculate time? Power is equal to work upon time. Power is equal to work upon time. Then time equal to work upon power. Work upon power. See, work is 440. So power is 11 watts. So it is nothing but 11 4 ja 44. So 40 watts. See, not watts actually, it is 40 seconds. 40 seconds is the time taken. 40 seconds. So in the given options, 40 seconds, option B is correct. 30 seconds wrong, 50 seconds wrong, 60 seconds wrong. So 40 seconds is the correct answer for this question. So next one, the ratio of kinetic energies of the two bodies 2:1 and their momentum ratio is 1:2. Then find the masses ratio is what? Here if you observe, see there is a kinetic energy ratio is given. See kinetic energy ratio K1 upon K2. Kinetic energy ratio 2:1, 2 upon 1. And momentum we have to, okay, see momentum ratio P1 upon P2. Momentum is denoted by P. P1 upon P2 is 1/2. So now masses ratio should be find out. To find the mass, kinetic energy is equal to, we know the formula, it is P square by 2A. So just now in the second question only we discussed. See kinetic energy is equal to P square by 2m. So now I can write the relation K1 upon K2 equal to P1 square upon P2 square into, so M2 upon M1. 2 is constant, you ignore. Now substitute the values. K1 upon K2, it is nothing but 1/2. P1 upon P2, so that is, sorry, K1 upon K2 is 2/1. See this is 2/1. So we will take here this step. See 2/1 equal to P1 upon P2 is 1/2. 1/2 whole square into M1 upon M2. M1 upon M2 or M2 upon M1. M2 upon M1. So now if you try to find out 2/1 equal to 1/4 into M2 upon M1. So that becomes 8/1. So M2 by M1 equal to 8 upon 1. So but the question is masses in the ratio M1 upon M2 should be find out, that is 1:8. In the given option 1:8 is the option D. The remaining answers are wrong. 1:8 is the correct answer for this question. So you have to solve like this, simple kinetic energy momentum relation we have to use in this problem. So this is about the question number 20. Then, so thank you very much. Thank you for listening. So thank you.